Before you start studying a technology, I encourage you to ask the question, why do I need it? OSPF is a routing protocol. Isn't it good enough? Well, it isn't for many reasons. The biggest one is the scalability issue. The internet routing table has grown to 1 million of routes, and that's only for IPv4. The shortest path first algorithm is incapable of handling such a large database. Then you have policies. BGP has a plethora of path attributes and tools that allow you to define policies for routes you will be advertising and those you will be receiving. And last but not least, OSPF can carry only IPv4 and IPv6 routes, while BGP is able to carry many more address families. We said that BGP allows definition of routing policies, but why do we need them? In the internet, we are responsible only for our routers. The neighboring networks fall under the authority of other administrations. We can control what we are advertising out, but not what is coming in. BGP through policies allows us to filter what is coming in and also control what we are advertising out. Neighboring routers cannot be trusted to send us correct information. A misconfiguration in a neighboring router, either unintentional or malicious, could cause disruption in our network. This is called a BGP hijacking. This is why we need to filter through the advertisements we are receiving. Before BGP, there was Exterior Gateway Protocol. You would say that BGP is also an Exterior Gateway Protocol. And yes, you would be right. But there was a protocol named Exterior Gateway Protocol, and it was an IGP. The biggest problem with Exterior Gateway Protocol is that it required a star topology, because it did not have a loop prevention mechanism. This is the same concept as OSPF. In the center, you have the backbone area to which other areas are connected. A star topology is not suited for the internet. That was the main drive into inventing BGP, to get away from this star topology requirement. You would ask, how does BGP overcome the star topology problem? BGP route advertisements have an attribute called ISPath. It is a list of networks called autonomous systems that the path goes through to reach the destination. When a BGP router receives an advertisement, if it finds itself in the ISPath, this means that the path has looped and it must discard the route. We will talk more about this later. I had just introduced a new term, autonomous system. It designates a network that is under the same administrative authority. The autonomous systems on the internet have unique numbers to distinguish them. Those numbers are assigned by the Internet Assigned Numbers Authority, or IANA. Earlier, we said that OSPF is limited to IPv4 and IPv6, and that BGP can carry more things. But what are those things? BGP was designed to be extensible. We can carry anything inside a BGP advertisement. IP addresses, MAC addresses, anything really. Even Shakespeare if you want. The important takeaways from this brief lesson. BGP is the only routing protocol that can carry and process routing tables as large as the internet. BGP has a plethora of options to control your routing according to a defined policy. BGP supports address families beyond IP.